Hello everyone and welcome to this training session on statistical process control. My name is Vamsidhar. We all should be aware that this is a very common buzzword, especially in the field of operations. People who are working in the areas of quality, they use this a lot, whether it is in the manufacturing industry or the services industry or even the outsourcing kind of an industry. Any kind of industry where the focus is on process, right? Whatever the process we have implemented to manufacture a particular product or to address particular calls or to service particular customers, whatever is the process that we are talking of, I need to know whether this particular process is consistent, whether the process is resulting in consistent results, or is it more like for a few people implement this very well, whereas a few people make a lot of mistakes. Then it is becoming more of a person driven, not a process driven kind of stuff. So, whenever we talk about the process is under control, it means that the process which we are following to produce the particular output is yielding consistent results. So, based on the actual results which we have got over a period of time, we analyze whether we are consistently good at executing a particular task, whether we are consistently good at executing a particular process. And that is what, when I look at it from a statistical standpoint, to say that my process is under control or my process is not under control, we use the concept from this chapter. And please remember, whatever we are dealing in this chapter is just a very basic introduction to the world of statistical process control. As I'm saying, statistics has its uses in multiple industries. This is one key usage which I can understand from the in the statistical world. So the major kind of things which we will look at as a part of the statistical process control is the control charts. What are these control charts? The charts, we'll look at it slightly later in the slide also, but one, the chart should be plotted over a period of time. This is one difference which we observe between this chart and the other analysis which we have done, especially the comparing the means or one sample tests and all these things. Whatever the tests we have done, they are different from control charts because there the data was not taken with respect to time, whereas in the plotting of control charts we always take the data with respect to time. So along with the, so for across the time, if I look at the variation in the data, is the variation more or less the same or the variation is changing continuously? I want to check that kind of thing. Or I may plot the control chart with respect to the means. On an average, is the mean number of calls, is the mean number of data that is processed is more or less the same, or is it not consistent? That's one more thing. And generally when I talk about attributes in this session, I am introducing you to the proportions. So these are the three words which we have used right from the beginning when we are doing a one sample test or two sample tests. We have been talking about means, variations and proportions. So the same three things, when I apply it to these manufacturing and the operations world and check out the consistency of the process, I'll use these control charts. So they always talk about whether the process which I am following to produce the output, is it statistically stable or not. And as I said, the whole data has to be plotted on a time sequence. Over a period of time is what the data has to be plotted, and the consistency check has to be done over a period of time. The most common charts which people plot is a runs chart, which is a very basic chart between the data and the time. Whereas R chart is also called as range chart, which is more to track your variation over a period of time. The X bar typically as being generally it's also being represented like this. The X bar is a representation of the mean, so which is used to track the consistency of the mean. And just that we have decided that we'll use attribute based charts. I'll also introduce you to the P chart, which is a proportion based chart, which is one of the attributes of your data. So these are the common kind of charts which we will discuss, but as a part of implementing statistical process control in the organization, there is much more to do apart from the understanding of these different types of basic charts. So, introducing you to the world of run charts. As I said, I'll take different dates, sequential dates on the x-axis, and whatever are the values, it could be number of calls handled, or it could be number of products produced, or it could be the width of the diameter of the brake which I am producing, or it could be the length of the rod which I am producing. It could be anything. That particular characteristic over a period of time, I am plotting all their values. And so the x-axis contains the dates, the y-axis contains the values. Now, once I plot a simple chart, running chart over the different dates, some things that I need to observe is any specific pattern. Sometimes going up, sometimes going down, or for first three observations it is up, the next five observations it is down, something like that. If it is there, any specific pattern that is present, or any cyclical nature that is observed in the data, probably first five values up, next five values down, next five values up, some kind of cyclic nature that is present in the data, or there are some unusual data points. Some values very high, whereas some other values are very low compared to the rest. If I have any of these three kind of things as a part of my chart, just by visual inspection I can talk about those things. If it has some kind of a pattern, the patterns could be like something that is going upwards continuously, or sometimes something that is going downward continuously, or probably okay, some point it was down, it was very small, but after that it has gone up, and again after that it was stable. Some kind of patterns like this, a continuous shapes if we am observing, either the upward or the downward trends, or shifts from up to down suddenly, or exceptional high values which are like unusual points, cyclical patterns. Any of these things if I am observing in my chart, I cannot say that the process is statistically stable. Only when none of these patterns are observed in the data, some variation that is there, as long as it is pretty natural in nature and it is not observing a particular kind of a trend, or a particular kind of seasonality or particular cyclicity, as long as it does not observe any of these things, whatever that random variation that is there, it will definitely be there in any process. I don't need to really bother about it. But if any of these patterns are identified, or if any of the unusualities or cyclicities are identified, then I talk about that there is something to improve in the process. So that's where the total variation, I will look at it from two dimensions. One is a random variation and the other one is an assignable variation. When I use the word random variation, whatever the variation that I am getting is just a coincidence. It has nothing to do with a specific factor, or it has nothing to do with some kind of improvement in my system. It will be inherent in every process, because I do make I cannot meet the deadlines always, or I cannot produce exactly the same number of products every time. So there is no assignable cost to it. Sometimes I did big, sometimes I did small. But if I am observing some kind of a pattern, which means consistently this is happening, which means there should be something to improve in my process. Similarly, if I'm seeing that there is an unusual high or unusually low data point, then also it's a pointer. Something has really happened. Please dig into it. So as long as it falls into any of those three categories, some kind of pattern in the data, in the graph, or some kind of cyclicity present in the graph, or some kind of unusual values. If any of these three kinds of things are being found in the graph, I can very well go with it as an assignable variance, which means some kind of causal analysis have to be done for that, so that the problem can really be addressed and the process can be improved. But if any of those patterns are not there, but still there is a deviation, I call it as a random variation, and I am not much bothered about that random variation, because it is inherent in every process. So the control charts, as I said, will plot for means, variance, and even the attributes. As a part of the control chart, let's say I'm talking about the typical means or something. Let's say this is a control chart. Along with the individual data points, we have three different points. One is a center line, one is a lower control limit, and one is an upper control limit. These are the three things which will be present for every control chart. So how do we determine what is the central line, what is the upper control limit and lower control limit? We'll look at them in a while from now. But whenever a particular chart has these four plots, one, the actual data points, then a center line, then a lower control limit and upper control limit, then that particular chart I call as the control chart. I can plot it with respect to means, I can plot it with respect to variances or proportions or whatever it is. But any typical control chart should contain these four numbers. Now the central line is nothing but it's the center value of the characteristic measurements. So all these points, I take the mean of all these points. I take the mean of all these points and I am plotting a center line. And based on some interval, we'll see the different methods of determining the intervals. Based on some interval association, I plot an upper control limit as well as lower control limit. And what it says is, if any one individual point, if all the individual points are lying within the control limits, upper as well as lower, then the process is more or less under control. Of course, there are a few more things which people have brought out to say the process can still be improved. But the basic thing is, as long as all my data points are falling between the the upper control limit and the lower control limit, I can very well say that my process is under control. So when I do this plot for the ranges, not the variances, I'm using range. Range is like a maximum value or a minus the minimum value during a particular period, because I am looking from the extreme standpoint, not an average deviation standpoint. So I am looking at the range chart. Generally for variation monitoring, people plot range charts. X bar is used generally for the mean monitoring, but generally both the charts are examined together to draw whether the process is under control or not, whether the mean is consistent as well as range is consistent. One of them being consistent whereas the other is not, it does not show me that my entire process is under control. So the expectation is the mean as well as the range, both of them need to be in control to typically say that my entire process is under the statistical control. All right. Then if I want to look at the range specific chart, I want to measure the consistency of the variation or the variance in the chart. So such kind of chart I use the R chart or the range chart. So I'll typically see whether my variance, whether the consistency, whether the range is consistent over a period of time or not. So I am more interested in looking at whether the variation of the data, not the mean. Here the process, here the mechanism is to look at the variation in the data, whether it is in control or not. And why are we considering the range instead of standard deviation? And what is typically the argument is range measures the maximum value and the minimum value, whereas the standard deviation measures the average deviation over a period of time, over a point of time. So moving ahead, we also will see that the requirements for plotting an R chart are typically they consist of small samples, all of the same size n. So if I'm talking about a 120-year data, probably I'll break it into 10 years data or 12 different samples of 10 years each, or 10 different samples of 12 years each. So it is more like the time period which I am taking is more or less uniform. When I'm talking about a range, the time period which I am considering should be more or less uniform, and the distribution inside that should be normal. Only in that case I will look at the control chart for R. And the key things, as I said initially, apart from each of the individual points will be ranges. The highest value of that particular period, let's say I'm talking about 120 days, and if I break them into 12 days of 12 periods of 10 days each, then within that 10 days I will see what is the maximum value and the minimum value, and I will take the range of that. That is my each individual point. Then along with that I will have a center line which is the average or the mean of all those individual points, and I will also have an upper control limit and a lower control limit. Typically the upper and lower control limits are created based on this assumption that the overall data, that all the points 99.7% confidence interval is what I will typically build, which is nothing but plus or minus 3 standard deviations. The reason being, we are assuming that the pattern of the data is more or less normal. Under that assumption, plus or minus 3 standard deviations will give me 99.7% of the data lying between those two confidence interval limits. So if any one value is lying outside that limit, I can very well take a conclusion that that particular value is an abnormal value, or my process is not statistically stable. That particular value is treated as unusual or an abnormal value, and the entire thing is not treated as statistically stable. Along with that, along with just seeing something that is outside the upper control limit, which is a 3 sigma level or a minus 3 sigma level away from the mean, that is one way of identifying the outliers or abnormalities in the data. But even if I see that there is some kind of a pattern in it, then also I'll say that it is not stable, or there is any point that is lying above or below the lower control limits, upper and lower control limits, then also I say that the data is not stable. These two are very common things. If any pattern is seen, no stable. Anything that is outside the 3 sigma limit, upper control limit or lower control limit, then also I'll say that the process is not stable. But this is a very common stuff. Rule of 8. All the eight consecutive points, they are all above or below the center line. If 8 consecutive points are above the center line, then also I'll say that the process is not stable. If 8 consecutive points are below the center line, then also I'll say that the process is not stable. But apart from that, people also use few other mechanisms. 6 consecutive points if they are continuously increasing or decreasing, which will show a trend kind of stuff. 6 continuous points if they are showing either increasing or decreasing, then also I can say that the process is not stable. 14 consecutive points altering up and down. One is up, second point is down, third period up, fourth period down, and so on. If I have altering up and down for 14 consecutive points, then also I'll say that the data is not stable. And 2 out of every 3 consecutive points, the 2 continuous points out of the 3, if they are beyond the 2 sigma limits, so which means they will be within the 3 sigma limit, but they are outside the 2 sigma limit. So 3 out of the consecutive, 2 out of the consecutive 3 at any point in time, if 2 periods out of the consecutive 3 periods, if they are outside the 3 sigma 2 sigma limit, though they are inside the 3 sigma limit, then also we say that the process is out of control. And similarly, 4 out of the 5, taking any 5 consecutive point, if they are 1 standard deviation away, though they may be below 2 standard deviations or 3 standard deviations, in all these conditions, people look at the process not being statistically stable. The same parameters apply whether I am going for an R chart or an X bar chart or a P chart or whatever chart it is. But the most commonly used things are these 3. But sometimes people also adopt these 4 also and say these are the various conditions under which I can say that the process is not stable and there has to be something to do to improvise the particular process. That's how I look at the control chart, especially the R chart. The only difference being, instead of plotting the actual values, I take a time period which is uniform, equal number of elements, sample size being uniform within each time period, and I take the range of each of those periods, and based on that I plot I take the mean of them. I take the upper control limit, taking the 3 standard deviations above that mean line, and the lower control limit taking the 3 standard deviations below that mean line. So based on that I will conclude whether my process is within control or out of control. Same thing for an X bar. The only difference is I am not bothered about the variance. I am more interested in the sample mean. Otherwise, the entire activity is still the same. I am plotting the sample means. I'll also get a central line, upper control limit, lower control limit, 99.7% confidence, which is plus or minus 3 sigma. That entire aspect and even the interpretation aspect is also the same in case of an X bar chart. Same thing if I look at for an attribute, I call it as a P chart. Once I know one chart, the remaining things, the interpretation of the remaining charts is the same. It graphs on it is based on the proportion. Again, I'll have a center line which is an average proportion. I have a lower control limit, upper control limit. The only difference here is the upper control, because this is a qualitative kind of a data, not a quantitative. The lower control limit is defined by this mechanism, P bar minus 3 times root P bar Q bar by N. So because here the standard deviation, which is the standard error, is defined based on root PQ by N. We have already defined. In case of proportion, the standard error is root PQ by N. And 3 times means 3 times the control limit. 3 times the standard deviation is the upper control limit. 3 times the standard deviation is the lower control limit. So I will define. So if this goes above 1, the proportion in reality cannot be above 1. So I'll take the maximum as 1. Same thing in case of minimum. If it goes below 0, I'll take it as 0 because the proportion cannot go negative. And P bar is nothing but the pooled estimate, total number of defects by total number of items. That is what is the pooled estimate. I'll take it as the central line, which is not a plain average or plain mean of the individual points. I'll take it as a pooled mean, which means for all the periods, I take the total defects, I take the total incident, and then find out the pooled mean, not a mean of the individual values. It's a weighted mean. That's where I am calling it as a pooled mean. So these are some of the charts which can really help to check whether our process is under statistical control or not. If not, what kind of actions that can be taken to improvise the process. Because from a perspective of operations or manufacturing or outsourcing, because we work on lots and lots of processes, the quality or the effectiveness of the process is very important for the future future profitability of that organization or that project. So this chapter had given you a very brief overview on how do I measure the process efficiency using the range charts, using the mean charts, and using the proportion based charts. I hope this basic concept is clear to you. Of course, there's a lot more to understand as far as statistical process control is concerned. If you have any further queries as far as this scope is concerned, you can very well feel free to call me on the number given below, 98480 You can even drop in an email to me at vamsidhar@pacegurus.com. I request you to visit my website www.pacegurus.com to get further updates regarding the training and consulting activities, as well as training videos which we do in the area of finance, statistics, analytics, and investments, as using the tools like Excel, SPSS, and VBA. I hope this session has given you a decent level insight into the understanding of statistical process control. Thanks a lot for listening to this session. Thank you very much.